All right, I'd like to talk about some of the properties of these definite integrals. So the definite integral is defined by the limit of the sum of f of xi star times delta x, I from 1 up to n, and the limit as n approach to infinity. So some of the properties, first property is if you have two functions that you can integrate, you know the integral of each one, okay, and you want to find the integral of the sum, you can then find the integral of the first function and the integral of the second function and add. That's because the summation sign goes through the sum of two functions. The summation sign can go through the two. And then the limit also, the limit of the sum is the sum of the limits. That's part of the properties of the limits. So you can justify, you can easily prove this property. Also, if you take the second property is if you know the integral of each one of the two functions, the difference, the integral of the difference is the same thing as the difference of the integrals. So those are two easy properties. Third property is the integral of a constant multiple of a function. Since the constant, you can pull it out of the summation sign and the limit sign. That's the property of a constant multiple of a sum. This also, you can pull it out of the integral sign and integrate the function first and multiply by the constant. Okay, that's another property. The fourth property is, let's say you have your interval from a to b and you made your partitioning and then you made the sum, you take the limit, but then you want to break it into two parts. So you want to find the integral of this section and then integral of that section. If you had those two separately, then the integral of this whole section is the sum of the integrals of these two sections. If you think about it in area form, that works, or if you think about it as a net area, that also works. But the summation, the limit of the sum will allow you to break it into two integrals. So what I'm saying here is the integral from a to b of f of x dx is the integral from a to c of f of x dx plus the integral from c to b of f of x dx. Okay? The next property is what happens if you want to integrate from some point a, or let's call it c, from c to c of f of x dx. What happens if you have the function, you have a point c, and you want to find the integral from c to c? Well, your delta x's will all be 0 because delta x was b minus a over n, but this is from c to c. So c minus c over n, this is all 0. So you're adding a whole bunch of zeros and taking the limit of a whole bunch of zeros. So that will be 0. So the integral from a point to itself is 0. And the next property is if you want to integrate from b to a of f of x dx, in other words, you want to go backwards. A is here, b is here. If you want to integrate that way, your delta x's will be on the negative side. So the delta x will be from instead of b minus a over 2 becomes a minus b over 2. So the delta x's will be just the negative of the delta x's if you were to integrate it from a to b. So going backwards will cost you a minus to fix. So the integral from b to a of f of x to x dx is the negative of the integral from a to b of f of x dx. So anytime you want to integrate it, you want to switch the limits of integration, it just costs you a minus outside of the integral. Multiply the whole thing by minus. That's what that property 6 is. So these are the properties that we will be using in the next few sections, but also these are just important properties to know.